climate change in aviation meteorology, particularly for New Zealand. And there'll be quite a few bits of overlap from what Jacob was just talking about. So continuing that conversation, which is reassuring that the industry sort of is in sync with the science. I'm going to focus on 6 particular impacts. And for each of those, we'll have a brief look at sort of the confidence in the science and the kind of time horizon we might be talking about loosely. And also just a little look at how well they might be met with existing aviation met products, or what might be needed in the future to help mitigate these issues. And after those 6, we'll just have a quick look at, I guess, more global implications of these. So let's get into it. So the most obvious one is increasing heat, obviously. For New Zealand in particular, we've yet to see really the impacts of this. We're certainly seeing the signal, but the impacts are a little bit further down the line, just given our situation in the world, being surrounded by ocean and not continental. But if there's anything we've learned about what climate change means, it's that a small shift in the baseline means much more rapid or extreme shifts in the ends of that distribution. So, global temperatures increasing by 1.5 degrees doesn't sound bad. Who doesn't want that at the beach? But actually that means far more extreme events. So in context of temperature, oops, wrong button. Context of temperature, here are some predictions going forward in terms of what that means in terms of hot days, in this case for Auckland. So the blue line is a very optimistic scenario if everyone did everything they possibly could. The orange line is a bit more, pessimistic or realistic, depending on your point of view. So we could expect something perhaps in between, but really this is all governed by human behavior, which we know is the hardest thing to predict. But if you do look at this orange line, this would suggest that by the turn of the century, Auckland could be expecting hot days pretty much every day throughout the summer period. And while a hot day here is defined as more than 25 degrees, this is in excess of 25, we could be looking at high 20s or even 30 degrees for several days, which has various downstream effects. So in terms of implications, the most obvious implication for aviation is just loading, and takeoff weights, etc., and aircraft performance. And this has already been observed to some degree in various parts of the world. The studies on this are fairly early, but we are seeing some signal here. In terms of other impacts, they really come down to humans, the human impact. So for GA aircraft, non-conditioned aircraft in particular, pilot fatigue could become an issue. Even for those aircraft that are climate conditioned, we're probably looking at increased costs for maintaining those comfortable conditions. And then there's ground staff implications. So much like we have now for wind limitations on ground operations, we could start seeing heat issues, as many places overseas already do. We did see a bit of an issue with melting runways in the Northern Hemisphere and their summer just gone. That might not be such an issue in New Zealand for various reasons, but there still could be implications for management, maintenance, and other assets. So in terms of aviation services, these aren't really covered by what we do at the moment in terms of temperature. But there are various things that could be, I guess, upscaled or weaved in the mix to include impacts from this. So we do temperature forecasts and impacts and derive products from this all the time. It's pretty standard stuff for us, whether this is just heat alerts, which we're starting to do already, or surface temperatures. So we do this for various industries such as roads or indeed beach surfaces. We do a fundamental physics based on radiative properties to determine surface temperature. And for aircraft loading even, you can take simple parameters such as temperature, air density, wind to derive your aircraft loading parameters. But in fact, this is stuff we do all the time in other industries where we take these multi-factored inputs that are not independent, and all of them having a risk or a probabilistic profile, and then turning that into a highly derived product. This is pretty standard stuff, so that could be something we start looking at. So the next one, we have already observed changes to New Zealand's rainfall profile. This is one of the more reliable um, outcomes from climate change, and yeah, pretty strong signals already being observed. This has implications for both flash flooding and the more prolonged sort of traditional heavy rain events, which can both cause disruption, but on very different timescales, and importantly, with different predictability. So um, as a consequence, we have different warning systems, we have different observation systems, we have different ways of approaching these two different threats based on their life cycle and timescale. Um, and that's very appropriate because the time you have in which to react is different, and therefore your dissemination has to be different as well. Now, you could argue that airports are generally more resilient. We've seen cases where that's not quite true, but generally more resilient than a lot of other infrastructure. But there is surrounding infrastructure that's important to the operation that may be more vulnerable, in particular things like transport. Now, this also, like heat, isn't really part of our normal traditional aviation service suite, but it is part of our standard day to day. We do this all the time, obviously, in terms of weather warnings, be that broad scale weather warnings or the small scale high impact stuff, such as severe thunderstorms that could result in lightning strikes or flash flooding or strong wind gusts. So this is sort of part of our bread and butter, but there could be ways of weaving this into the operation across the industry. Um, and I think an important message here, which I'm already hearing from some of the groups here, which is great, is about interagency cooperation. So systems integration, intelligence integration is really part of the package here, because if it impacts one part of the supply chain, it's going to have downstream effects. Okay, the next one in terms of in-your-face impact from climate change is the nature of storms. Now, this one has a little bit more uncertainty to it in terms of what it means for New Zealand. The heat and the rainfall or flooding profiles are fairly well captured. Storm systems themselves, we are seeing signs of different storm character, and that is following really what the science would tell us to expect. The tricky bit is, do they hit New Zealand? So storm tracks in terms of climate predictions are a little bit uncertain. Just as with tropical cyclones, indeed, there have been various predictions about the severity and the frequency of tropical cyclones in a changing climate, and there's still a fair bit of uncertainty around that. What we can say, although, however, is that storms can be expected to change in their nature. So that the sample set of storms that we see in the New Zealand area is already seen to change. If you remember the last winter we've just had, we had an ongoing succession of subtropical lows affecting northern New Zealand. I mean, how ridiculous is that? And throughout our winter period, subtropical lows were dominating our weather system. Now, that's partly a function of La Nina and other sort of broader seasonal climate factors, but it's also something we're expecting with climate change. And these have different character. These sort of hybrid systems with subtropical character have different predictability again, and different rainfall and wind distributions and characteristics. So this is a signal we are starting to see and something we expect to see going forward. Impacts are pretty obvious, certainly disruption to the aviation network. And with these large-scale systems, they can, of course, affect multiple centers simultaneously. So your diversions become more problematic and other downstream effects. You might also see more crosswind issues if you get severe storms turning up in the wrong place, or in places that they're not used to. We don't usually see in a historical record, and associated shifts in the up-level winds, which should just be periodic with the passing of storms. Now, to some degree, these are covered by traditional Met products. Of course, we do track storm systems and the threats they provide either en route or at aerodromes. But there could be additions to this service. So again, things like warning services we have for other industries, or even outlooks incorporating longer term threat profiles into your planning could become more of some part of that planning strategy to look at for operational efficiencies, along with things like the flexible airspace discussed and perhaps more rapidly updated Met intelligence. And again, I think interagency coordination is important in this space. Sea level rise. Now, this is actually one of the easiest things to predict with climate change. It's pretty darn obvious. If you have a temperature profile of the future climate state, you've got a pretty reliable sea level rise. The only question with sea level rise is the rate of that rise. There is quite a lag, and that gets very complex, talking about glacial movements and so on. But yes, generally, it's a very reliable signal of sea level rise. And just noting here on the right some of our lower lying aerodromes, you can see that we don't have a lot of room to play with some of these aerodromes, and even some that are coastal. I mean, New Zealand's a very marine surrounded environment, lots of coastal aerodromes, even some that might not seem very low lying. I've got Wellington here as an example, plenty of reclaimed land around there. And in fact, the access itself could be vulnerable, even if the airport itself might not be that low lying. So storm inundation is obviously becoming more of a risk. So over time, along with things like erosion, which might affect planning and future developments or maintenance. And in terms of the predictions going forward, again, it depends on the scenario, the emission scenario you're using, and in terms of the science around sea level rise, which comes down to ice loss from Antarctica, etc., that really just affects the speed at which that sea level is expected to rise. But most scenarios you look at, again, by the turn of the century in New Zealand, most areas can expect in excess of 0.5 metre of sea level rise, and that'll just keep on going. We're committed to much more than that over the next few centuries. But if you sort of base your thinking on, 0.5 metre to 1 metre, that's a lot of aerodromes to be affected in some way or other. And again, it might not be the airport itself affected, it could be some supporting infrastructure or service. And again, this is not really part of our typical aviation service suite, but it is what we do in other sectors. So we do provide warning services for councils and other coastal managers. Perhaps this is something that might start to become more relevant to airport management and downstream also to other industry players, and certainly a role for future design and planning. Getting back to the weather a little bit, there is still some uncertainty about some of the science here, but I think there is a very strong signal that we can expect to see a shift in the weather makeup, in particular the convective character around New Zealand. So we can expect an increase overall in the convective nature of our weather. And although the frequency is perhaps a bit open to debate, more severe storms are likely. And I've just made a note of hail here. We've all seen scary, nightmarish images of the impacts of large hail to aircraft overseas. We've had a bit of that here, but we've mostly been lucky. I think we could start seeing that become more of an event. Now, these are, of course, covered by traditional Met service products such as SIGMETs, and hopefully we can capture that in a TAF as well. But there could be different ways of looking at this. So the way we ingest information into the production of TAFs and other warning services could become more efficient. Again, the incorporation of severe thunderstorm cell watches and warnings into these systems could become more of an important part of that. And again, we've already mentioned flexible airspace and other adaptive techniques. And yeah, also, I think Jacob mentioned flight planning as well. And lastly, smoke. It's normally something, so bushfires is something we traditionally sort of sympathise with the Australians for, but increasingly that's become a bit of a New Zealand thing as well. So we've sent fire crews to assist with Australian issues before, and they've started sending more of their crews to help us. So it's become a bit of a seasonal thing over here, and it's very likely to be increasing going forward. So obviously we have the issue of smoke as a visibility limitation, But even the fire itself could be a hazard. I worked in Australia where we were shutting down coal-fired power plants and other industry components because of the fire risk itself. That could become more of an issue here. And in fact, if you remember the late 2019 bushfire event from Australia, from which this image is taken, very large swath of smoke covering the country, and it did so for a few days. We observed various changes to the cloud characteristics. So the actual optical properties of clouds changed, their opacity changed, and in fact, even their charge carrying capacity changed, and the way that distributed lightning changed. So again, this could be something, another thing to deal with going forward. And with that drying environment, also the risk of dust storms. So certainly people who forecast in various parts of the world routinely put dust storms into their TAFs. That might be something we have to start considering here a bit more. So again, this is nominally included in aviation products, but we might need to consider a few other adaptations as well. So those are just 6 key impacts in the New Zealand context. What if we put that into a global context? Well, of course, these issues affect the globe. They're not New Zealand specific, though they might have a New Zealand flavour. So to greater or lesser degrees, all parts of the world will be encountering these, and certainly then you talk about long haul or even regional flight efficiencies and so on. We can be looking at changes in wind profile and so on. So the impacts we see globally really come down to 2 categories. One is purely the meteorology, and we've already mentioned a few of those. So the meteorology certainly is going to be impacted, and there's some good bit of science going into predicting that going forward. The other one is the human factor, and if the last few years have taught us anything, it's how tricky the human factors can be in predicting them, but also how significant they can be on the implications. So the human factors here, of course, can affect the market, as already discussed, also investment signals, and then actually geopolitical stability. That might sound scary, but it is really ultimately the single biggest threat of climate change is political stability globally. And any organization with a long-term horizon is considering that as part of their strategy now. So just to wrap up, it's not a cheery message. Really, I'd say the summary is to expect further change and disruption. I know the industry has faced plenty of that and is already pretty well built for some of that, but this is just going to be a never increasing issue, particularly with climate change. But there are things we can do about it. So building resilience, there is a cost to come with that, of course, but at least we've got some pretty good investment signals here. There are some pretty standard techniques now and good approaches to build in predictive measures to allow forward planning because of climate change. And yeah, some of these are technological, others are just about how we go about our business. And one reassuring thing here as well is, the message coming from all the industry leaders globally is pretty consistent here, and that it is going to take a integrated response. It does come to communicating across various parts of the sector to increase that pool of intelligence and to use it the best way we possibly can. So I might just leave it on that slide since there are a few words there, and happy to take any questions if there's time.